Hi, AP Calculus students. Welcome to section 5.6, derivatives of inverse trig functions. So you had worked in Algebra 2 and pre-calc with inverse trig functions. You remember that what an inverse trig function does is when you've been given a trig function, that ratio of one side to the other, like tangent opposite over adjacent, sine opposite over hypotenuse, cosine adjacent over hypotenuse, that when you've been given that ratio of one side to another, right, which shows up as a fraction, that it gives you the angle where that trig function happens, right? Sometimes they use a -1 to show the inverse. We don't really, which is actually confusing because a -1 is also a reciprocal, and these are not reciprocals. These give you the angle when you have these trig functions. And so in calculus and really in college, we don't use the inverse -1 symbol. We use the word arc. Arc tangent, that's the same thing as inverse tangent, but more clear. Arc sine, arc secant. Okay, so we have a list on the board of the derivatives of these inverse trig functions. A couple of things that are helpful though. If your inverse trig function is an inverse of a trig function that begins with a C, cotangent, cosine, cosecant, then you have the negative of the matching trig function. So kind of helps you with memorization and patterns. Also, don't forget the chain rule. If you have where x equals f of x, if you have a function here rather than x, the function will also be here and the derivative, you will multiply by the derivative of the function. Again, if you have a function here, the function will go here and you'll multiply by the derivative of the function. So let's go ahead and try, oh, and by the way, I have a little note to myself. This is the last function that is new that we will be taking the derivative and an integral of. In sections chapter 6 and 7, we are just applying all the functions we know and all the calculus operations we know. Okay, so let's go ahead. On number 43, they give you the function is 2 arc sine of x minus 1. Notice that there is a function where the x would be. I'm going to be sure to use that appropriately. They were asking for the derivative. So the derivative would be 2 times the derivative of arc sine of anything is 1 over the square root of 1 minus anything. There we go. Do I have, nope, don't need another parenthesis. Oh, I need a square. There we go. I was forgetting something. Times the derivative of the inside function, but that is just a 1. So this is perfectly correct, but they do a little work in the book with this x minus 1 squared. So let's go ahead and do that also. 1 minus x squared minus 2x plus 1, right? And then we get a 2. 1 minus 1 is 0. And then we have a positive 2x minus x squared. There we go. There's your derivative. On number 50, they asked for the derivative of x squared times arctangent 5x. So we are just going to use the product rule and talk our way through it. The derivative of x squared is 2x times arctangent of 5x plus, I'm going to keep my x squared and multiply by the derivative of arctangent of 5x. Again, this arctangent, I would say arctangent and arcsine are the most common on the AP exam. Notice that I have a 5x function where my x is. So it'll go here, here, and I'll take the derivative. So here we go. The derivative of arctangent of 5x is 1 over 1 plus 5x squared times the derivative of the inside function is 5. Let's go ahead and clean that up just a little bit. The first term is fine like it is. And the second term is 5x squared in the numerator and 1 plus 25 x squared in the denominator. You could also factor out an x from both terms, which I would have expected they would do on the in the book, and they didn't, because they do that often, right? Anyway, they left it like that. On number 58, they are asking for the derivative of this crazy expression here. So let's go ahead. We have a product rule here. This is x times arctangent of 2x minus 1/4 the natural log of 1 plus 4x squared. You may ask why they throw it in there, and you'll probably notice why in a second. So let's use the product rule here. The derivative of x is 1. I'll keep my arctangent of 2x. Plus, I'll keep my x and multiply it by the derivative of arctangent of 2x, where this is 2x is my function. That would be 1 plus 2x squared times the derivative of the inside function, minus 1/4. The derivative of the natural log of anything is 1 over anything times the derivative of the inside function, which is 8x. Okay, I think I'm in the way. Let's take a look here. Notice then that this 4 cancels and leaves a 2 here. Now, this is interesting because when you take a look, here's our first term, arctangent of 2x. Take a look at the numerator here. It's 2x, and the numerator here with the minus is 2x. Take a look at the denominator here. This is 1 plus 4x squared, and so is the denominator. So what you have is this term and this term are the same, and they're being subtracted. And so you're just left with arctangent of 2x. That's why they did this here. Okay, next on number 66, they ask for the equation of a tangent line given y equals arcsecant of 4x at the point square root of 2 over 4 and pi over 4. So the first thing I'll do is put in the point, pi over 4, square root of 2 over 4, square root of 2 over 4. There we go. So all I need now is the derivative of arcsecant of 4x, and I'm going to evaluate it at the square root of 2 over 4 and substitute it in, and I'm done. So let's go ahead. The derivative of arcsecant is right here, where if I have an x, it would go here and here into the derivative. Notice that I have a 4x, right? So a 4x will go here, in here, in here, and then I'll be sure to use the chain rule. So I'm looking over at my arcsecant, the derivative of it, that's 1 over the absolute value of 4x times x squared. So if it's okay with you, right here is what I'm going to square. 16x squared minus 1 times the derivative of the inside function, which is 4. There we go. Notice that this 4 cancels out this 4 here. So let's evaluate our derivative at the x they gave us. We're going to put a square root of 2 over 4 here and here. All right, and we're going to work that out. Let's see. So we have a 1 in the numerator. This is the square root of 2 over 4. When I put a square root of 2 over 4 in here and I square it, I get 2/16 times 16. So the 16s cancel out, and I am left with 2. 2 minus 1 is 1, and this is the square root of 1. So I don't need that. So the derivative at the square root of 2 over 4 is the reciprocal of 1 over over the square root of 2 over 4. So I'll flip it. This is perfectly correct, but they probably rationalized it by multiplying the top and the bottom by the square root of 2. Notice in the denominator, the square root of 2 times the square root of 2 is 2. 4 divided by 2 is 2. And I get 2 square roots of 2 is the derivative. That's actually it looks kind of fuzzy. 2 square roots of 2 on the edge of the video there. There we go. And here is our equation of the tangent line. Okay, the last thing I wanted to do is help set up number 97 with you. So I'm just going to erase a little bit. You could fast forward. I do have a pause button on videos, but I have this irrational fear that if I hit pause, that it won't start back up or the entire video will disappear. So I get, if you ignore me while I'm erasing, number 97. Here's what number 97 says. And they give a picture. So I'll draw the picture first. So they have a theta, they have a 5 miles, they have an x, and here is a plane. I'm not good at drawing planes, so there's the plane. It says, an airplane flies at an altitude of, I just realized there's a guy here, at an altitude of 5 miles, 5 miles up, toward a point directly over an observer. Consider theta and x as shown in the figure on the next page, and here it is. And here's what they want from you. It says write theta as a function of x. And then they want you to take the derivative of it. So I thought I'd help you set this up. Okay, well, when I look at my right triangle, I can see that I have an opposite side and I have an adjacent side. So what I can start with is that tangent of theta equals 5 over x. Okay, 2 problems here. First of all, they want the theta alone. It says write theta as a function of x. So because I'm going to be focusing on the angle, I'll do an arctangent, maybe. Because I don't really like this 5 over x. Can I go ahead and do the derivative of that? Maybe, but at the same time, I think that I'm much better with an x in the numerator and a 5 in the denominator, right? In other words, instead of tangent, I think what I actually want to use, and we don't use it really all that much, is cotangent, right? Because this is really 1/5 of x. I am really good with that derivative, okay? Now, how do I write this in terms of theta? Here's my angle, and this is what cotangent actually is. So I'm going to use arc cotangent. So if you have been given cotangent, right, and you're trying to find the angle, that is arc cotangent, and it will give you the angle. So I have written theta in terms of the function. So that's for A. And then what you can do from there is go carefully and take the derivative, right, and answer their questions. The derivative is going to be with respect to t, right? So you are going to have a dx dt right here because there's not a t in your function, that's an x. So I'm sure we will end up working on it together, but I'm hoping this can get you through to where you can do it on your own or get very far to start. And that is all for 5-6. Have a good day.